Okay, so what if everything you think you know about the end of the universe is, well, wrong? What if the end isn't a cold, dark void? Today, we're diving into a really fascinating new idea called phase equilibrium. And trust me, it completely flips the script on the ultimate fate of, well, everything. This is it, right? The biggest question of them all. We usually imagine a cold, dark, empty void as the final chapter. The heat death. Just nothing. But what if that's not the real end of the story? What if the universe doesn't just die? What if it transforms into something far, far stranger? So, this framework has an answer, and it's called phase equilibrium. The idea is that the universe eventually settles into this final, perfectly uniform hum. Think of it this way: instead of fading to black, all the complex, messy knots of matter and energy, stars, galaxies, us, they all just smooth out. And what's left behind? Only the fundamental eternal vibration of space-time itself. All right, so here's our game plan for this journey. We're actually going to start at the end, the universe's final state. Then we'll jump all the way back to before time began. We'll look at the fracture in space-time that created everything, unpack the rules of our universe, see how it all phases out, and finally, land on what this new kind of nothing really means. It's going to be a trip. Okay, first up, the universe's final state. Let's dive right into our cosmic destination. What does this place, this phase equilibrium, actually look like? Right, so the big takeaway here is that the end isn't just about things getting cold and far apart. No, it's way more fundamental than that. It's about the very fabric of reality undergoing a phase transition, kind of like water turning into steam. The universe doesn't die. It transforms into its final, most basic state of pure oscillation. But to really get a grip on that end state, we have to do something a little weird. We need to go back, way, way back. Back to what things were like before our universe even began, to a state of perfect timeless symmetry. Before the Big Bang, this idea suggests there was a state of phase coherence. I want you to picture a perfectly synchronized, oscillating sea, a single, unified, timeless vibration. There are no separate things, no objects, no before or after, so no time. And get this wasn't chaos, it was the complete opposite. It was the ultimate, pristine state of order. So why all this talk about oscillation? Why not just stillness? Well, this framework makes a really profound point. For spacetime to even exist, it must vibrate. A perfectly static still reality, well, that would be the same as nothing at all. It wouldn't be anything. So in this view, existence itself is oscillation. To be is to vibrate. So, if the primordial state was one of perfect, unified vibration, what happened? Well, that perfect symmetry, it seems, couldn't last. It had to break. And that one break was the birth of our entire universe. So you need to throw out that picture of a giant firework in space. The Big Bang wasn't an explosion of matter. According to this, it was a geometric event. It was the moment that the single unified oscillation of space-time fractured, losing its perfect harmony and creating localized complexity for the very first time. So here's how it happened. First, that global oscillation became unstable. It just couldn't hold itself together anymore. Second, fractures formed, kind of like cracks in ice. And this is the crazy part. Number 3, within those fractures, space-time literally tied itself into stable, self-locked knots. And those knots, that's what we perceive as matter. And finally, as soon as you have those knots as localized reference points, you get a sequence of events. That's when time begins. Now, this fracture didn't just create stuff. It created a universe with a whole new set of rules and new objects that drive its evolution. And these are the very engines that push our cosmos towards that final state of phase equilibrium. Let's really dig into this, because it's a huge shift in thinking. What is matter? The standard view is that particles are like tiny objects existing in space. But this framework says, nope. It says there are no separate things. Matter is simply what spacetime is doing when it twists itself into a stable geometric knot, which means we are fundamentally patterns of trapped geometry. Wild, right? And black holes, they're the ultimate expression of this idea. We usually think of them as just collapsed stars, right? But here, a black hole is a region where space-time has become so tightly wound that it forms a knot of maximum stability, a maximal phase-locked knot. They're not cosmic mysteries. They are the purest form of space-time's geometric nature. This gives us a whole new way to think about entropy. It's not just disorder. In this view, it's a measure of how desynchronized spacetime's vibration has become. Every single particle and every black hole is a permanent knot, a permanent wrinkle, preventing spacetime from ever snapping back into that original, perfectly coherent state. Okay, so now that we have all the pieces of fractured spacetime filled with these knots that drive entropy, we can finally return to the end of the universe and understand how we get there. So what's pushing everything toward this final state? Well, first, there's dark energy. Here, it's the residual tension from the Big Bang, constantly trying to smooth out all those knots in spacetime. Then you've got cosmic expansion, which just spreads everything apart. And finally, there's the growth of entropy itself, ensuring all the different vibrations naturally average out into one single uniform state. This leads to the key question, the one you're probably asking right now. If everything smooths out and all the differences dissolve, does that mean the universe just becomes a silent, static void? Is this just a fancy description for the traditional heat death? And the answer is a resounding no. This completely reframes the whole concept of heat death. Maximum entropy doesn't mean the end of all motion. It simply means the end of structured motion, the disappearance of all differences, the fundamental vibration of existence itself. That carries on. So the universe doesn't end with a whimper. It settles into an eternal, uniform oscillation, a cosmic hum. No stars, no galaxies, no matter as we know it. Just the pure, vibrating essence of space-time in its final, perfect equilibrium. This brings our whole story full circle, from one state of uniformity to another, and in the process, it redefines what we even mean by the word nothingness. So you see, the universe begins and ends in a state of uniformity, but they are two totally different kinds of nothing. The beginning was a nothing of perfect, coherent order before time existed. The end will be a nothing of perfect, featureless equilibrium after all structures have dissolved. Our entire universe is just the complex, beautiful story that unfolds between these two bookends of simplicity. And that leaves us with one last really fascinating thought to chew on. If this entire cosmic saga, from the initial fracture to the final hum, is just the life story of a single, evolving geometric object, what does that really make us? What does that make the temporary, complex patterns that we call life?